For the last year or so, I have been very heavily working with Azure Databricks, and specifically in using it to process big data using structured streaming. So I've been working for a major retail company, and in that project, we've been streaming multiple sources of data from multiple locations around the world, and streaming that all using Azure Databricks and structured streaming. So we'll kind of go through some of that and some of the things I've learned and picked up along the way, and hopefully it'll be educational to you, and we'll get started. So your current situation, I think these were the questions that Crystal put out there. So do you currently have some high volume data that you're trying to process in batch format? One of the streams I'm currently working on is 20 million records a day. Each record's somewhere in the neighborhood of a meg or two. So very large data set, 50 or 100 million actual records once it's processed out. So we're streaming that in real time at this point. So my customer I'm working with came over actually from a batch process. And so they had in their roadmap that they really wanted to get to real-time insights. They're trying to move to delivery from the web, trying to do other things like that, where they needed to actually know what their customers were doing, what they were buying in real time, to be able to respond to disasters like we're all living in now, to be able to figure out what the next thing their customer wanted to buy. Those kind of IntelliSense things that you see on websites like Amazon, or they wanted to be able to do that kind of machine learning and have that kind of knowledge available as well. And maybe you have some knowledge. I didn't see the final answer to the final question, but hopefully you have some knowledge of Databricks. I'm not going to go too in depth on setting it up, provisioning it, any of those types of things. But we'll hope you have at least some basic understanding of what Spark is, what Azure Databricks is, and we'll take it from there. And so you're probably, if you're on this call, you're probably kind of like me. When I went into it, I was more of a developer, much less I knew what Spark was. I had used it a little bit, wasn't super familiar with it. It seemed really hard in the past. So that there was a lot of setup, there was a lot of maintenance, there was a lot of work that had to go in just to get the ecosystem up and the environment working for you. But once I got into Azure Databricks, I loved it. You're able to use multiple languages. You're able to scale it up and down as needed in the cloud, like you can with all the Microsoft Azure tools. And so it really took all of the things that made me not want to use it in the past, took those out of the way, and made it so that it became just an incredibly powerful tool where I could process an insane amount of data at one time. So the architecture we started out with, something where we had all of our stores. They would pass that information to a couple of different source systems. Those source systems would then we would extract data out of those, put them in some sort of a file system, and then use Azure Data Factory to pick those up. And we did that kind of on a daily batch type process. So beginning to end took several hours to run. We only ran it once a day, and we would get good information at the end, but it would take a long time. And if it was 8 o'clock in the morning, it would be 24 hours before we knew what that customer was buying or what they had bought. So what we wanted to go to was a new architecture where we were able to process that in almost real time. So we were able to replace, instead of going through the source systems and doing an extract, we wanted to be able to stream that information directly to event hubs, and then from event hubs pick that up as a streaming source using structured streaming in Databricks, pick that up, and then populate all of our data from there. So from this point, I clicked too hard. Okay, so from this point, from the store, within a minute or two, we were able to get to the final resulting data that we could use for our analytics and reporting purposes, and get all of the information in real time streaming through this entire process like I said, tens of millions of records per day, hundreds of millions of individual transactions at the end, and stream that all directly out of Databricks. So why did we use Databricks? That's kind of what I was just saying, is that I had worked with a lot of big data systems over the years and several different platforms, and I'd used Spark before, but it was a lot more of a data architect and developer, much less of like a systems person wanting to try to keep that Spark ecosystem up. A lot of those elements, when you had to get under the hood and kind of set things up and tune them, I just really didn't want to do that. Especially as we moved into Azure and the cloud, I could just throw more hardware, more resources at a problem. So if I had a data warehouse or a SQL database that was really not up to the task of the data I was working with, I could just throw more hardware, and let that resolve it. But with Azure Databricks, now I can get the best of both worlds. I got simple setup. It's simple to maintain. It's easy to scale. The Spark system based off all the development and processing benefits without all of that technical and administrative overhead that you could have had in the past with Spark. So it really makes it, you get the best of both worlds, the best technology to handle the problem I had, and an easy way to manage and maintain that. You also get great integration with all of the other Azure elements. So you can use Event Hubs, you can use Key Vault, you could use Data Lake, Azure SQL or Data Warehouse, Synapse, Data Factory, and it even integrates directly with Azure DevOps. So all of the tools that I was used to as an Azure developer, all of the things that I wanted to be able to use, integrated directly in with it. And then also I get to overlay my existing Azure security model with Active Directory right over it to provide kind of that completely integrated security model. And so you can do a lot of things in Databricks. You can do batch-based processing there as well. I've done some of that as well, but really the structured streaming then allows you to take all of that integration and that processing power and apply it to a stream of big data to gain that near real-time processing capability. So you can just process huge amounts of messages, events, files as they are received, and perform the same computations on that data that you could with a static data set. At the same time, Databricks automatically keeps a record of the data where it was processed, allowing an almost seamless restart if you have a failure or if some sort of error were to occur. So it's almost seamless restart or seamless return to stasis if you have some sort of problem moving forward. So this allows you to really generate a data set in near real time, like I said, and provide those marketable insights for your business as you move forward. So what kind of sources can we have? They are a lot. These are the ones that I have used for different purposes, and mostly because, again, they're Azure. We're in the Microsoft ecosystem most of the time, so we're going to be utilizing those types of sources. So I've used the Azure Event Hub, the IoT Hub, Databricks Delta, which is a data table file-based database format in Databricks. Also used other file formats, streaming like JSON or XML, using the autoloader from Data Lake, so I can automatically monitor a file queue in Data Lake. When a file is placed there, I automatically pick it up and process it into my stream, just as if it was an event coming from an IoT device or anything else. You can also use some other things. Kafka is very, very popular in Databricks as well. Then there's this place called Amazon. They also have technology you can use sometimes. But Databricks is also available in AWS, and so you can utilize Amazon S3 or Kinesis or any of the other things that you might want to utilize over there as well. And then there are lots of different syncs. You can sync back to Kafka. You can do lots of things like that. But the real standard, the real power of it comes in when you utilize the Databricks Delta and write directly to that. So you can also write to almost anything else using for each batch function that we'll talk about and demo later on in the presentation. Nope, too far. Okay. So structured streaming. Structured streaming is really made up of kind of three separate parts. You have your source parameters, the thing that says where you're getting the messages or the files or the data from, and those have parameters such as the source format, the location, the number of files or number of events that you'll be consuming. Then there's a series of transformations, which you can do just about anything you could do in Python or Scala or SQL, and utilize any of those languages to do transformations of that data. And then you can then output it and have output parameters to be able to output it in multiple formats to any location that you want to. And then there's also this concept of the checkpoint location, which is very important in the streaming. That's what keeps your state and lets the system know exactly where you ended up. So if you're consuming, 1 million messages an hour and your cluster crashes and you lose your stream, you can immediately just start that up. It knows exactly where you ended and will start exactly at that point moving forward. So we'll do a little demo here. I can get the right screen come up. So kind of to look at that, this is what we were just talking about. So we have, again, those kind of three separate areas of, oh, that's not the right one. Those three separate elements of the stream. You have the concept of the source. So where am I going to get the information? In this example, I'm getting it from event hubs. You then have whatever options are applicable to that. So in the case of my event hub, I have a connection string that's connecting me back to my event hub. I have where do I want to start? Do I want to start at the beginning of the stream, the end of a stream, a certain spot in the middle? However I need to do that. And then you also have the number of events that I'm going to trigger. So if this was a file-based one, I might have set max files per trigger, so that I could control how many files or how many bytes I even picked up. The next part is, again, your transformations. So I can get all those transformations. Anything that I want to do, I can add additional columns, do calculations, drop columns, rename things, all of those, any of those kind of standard things. You can also do any other complex kind of calculations or aggregations, anything else that you would need to do from a transformation standpoint to get the resulting data set that you needed. And then the bottom would be your output. So it's going to say, I'm going to write this out to Delta. I'm going to put a partition on it. I'm going to append that data instead of overriding it or updating it. And then I'm going to have my checkpoint location. So this is the important part of the streaming, where it's going to identify, where am I in that stream. So as I receive more and more messages, it will keep track of that state, and then if I were to restart the stream, it would start from where it ended. And then any other options that you may have, in this case, a file location, could be a Kafka queue that you're posting to, or anything else kind of thing that you might be sending that information. And you can also break it up. So I don't want to make you think that you have to keep it in kind of this, it all has to be in one thing. A lot of the demos and things I've seen in the past show it all as one deal. And so I'm like, that's not really the way it normally works in the real world. You usually have multiple different steps where you're breaking up the work as you're going through the process. So here again, I have my load where I would get a data frame that had that information. Then I would have my transformation step, where I would do any of that kind of work, and then my output step where I'm going to write that information out. Let's give this a quick try. Always love live demos. Hopefully it'll work. And we'll run that. And so now I've created, oh, I did get an error. I'm not sure. Oh, I changed my connection so now it doesn't like my checkpoint, but that's fine. We'll just go on to the next part. So you can do other types of transformation. So one of the common things that you might do is do an aggregation. So you could stream directly in from that. So that one should work. Yes. And so once you start the stream, it'll begin with this stream initializing. And so that's going to then again go out, figure out what your state is, what was the last message that you processed, pick up at that point and start either loading your files or in this case, loading events off of the Event Hub queue. Just a second, it will get started up here. And so for this particular one, I'm accessing my Event Hub queue. I'm starting at the end of the stream, so I'm not going to pick up any old messages that might be just sitting out there. I'm going to pick up 100 messages per trigger, and so the term they is used kind of micro batch or mini batch interchangeably of how this runs. So it picks up a set of triggers. You could have 10,000 of them out there, but it's only going to pick up the first 100 maximum and then process those through. Didn't have it very warmed up here. And you can look inside and see what individual jobs are being run. If you wanted to get any detailed information on those, you can pick those up and see exactly what processes are being run. I got this on a pretty small system, but I'm surprised it's taking this long. So once this starts up, I'll be able to actually see the stream in process and see as it picks up records and processes those through. And then it should start to even display the records as they come through. Here we go. There we go. So you can see now I have this display query 36. I didn't give it a name, so it's just picked the default name. Hasn't picked up anything yet, hasn't picked up any messages, but I can send some messages into my Event Hub. And then in just a second, we will see those start to process through. And you can see both the number of messages coming in, your throughput, along with the duration of your batches, so that you can tell how fast your records have been coming in. And then also if you're using any kind of state, like you're keeping track of a certain thing. So in this case, my state is based off of my grouping, which is by state, I believe. Yeah, so I'm grouping by state. So I have 50 states, and so I get 50 aggregated items that the stream is keeping track of, and just adding more information to those. So as I get more and more sales by the individual states, those are going to be loaded up and added to that in real time. Okay. So that's kind of the very kind of basics of the streaming and how you would utilize it to, in this case, I'm getting some aggregation, some analysis of my sales that are coming in. The other things you can do is you can then take those streams and you can join that information with any other type of information. You can join it with other static information if you want to, if you need to add in like some dimensional information. So in the case of this, I have a territories table. So based off the state that it's in, those are identified as different salespeople in different territories. And so I can join that information just like I would in any other database operation to my streaming data and then get additional information based off of that. You can also join streams to other streams. So if you had two streaming sources coming in, you could join those together. I worked recently on a project where we had 9 streams that joined together at the end. That didn't work quite as well as you would hope. Gets a little confusing, and we'll talk about why that is here in just a minute when we get to watermarks and time constraints. So you get kind of some interesting anomalies when you start to add multiple streams together. So the first thing we'll talk about is doing a stream to static join. So I have a streaming table. I have my transactions that are coming in off of my website. They are, I'm flowing those in as they occur in real time. And then I want to add some static piece of information. So my example I have is a territories file. And then I'm going to join that information based off the state that the customer was from, and then write that information out to a data lake or do some other kind of analysis with it. So we'll hop back over to our demo. We'll go to our static join. So here again, kind of the same thing. We have our connection to our event hub that we're using as our streaming source. I then have my static table. So I'm just loading this flat file table. It could be a database, could be a Delta table, it could be anything out there. In this case, it's just the delimited text file. And I'm going to use that as my static piece of information. And then I'm going to have my streaming pieces of information from my event hub messages. I'm going to stream those out. And then here in this last step, I'm actually going to join those two together. So I'm going to take my event hub messages. I'm going to join those to my territory data frame. And I'm going to join them based off of the state. And so within my event hub message, I actually have a structured JSON object. So I can actually go in and identify specific elements out of that file, out of that structure to be able to join on. So instead of just having a column called state, I actually have a structure called transactions. And then within there, I can go down and drill down until I actually receive the state to the state element. And that's what you see a lot of, especially with Event Hub or IoT Hub, is that your message will actually be in XML or in JSON, and then you'll utilize that to create additional columns in your data frame. So I start this up. Hopefully it won't take as long as it did before. Should be all warmed up now. There we go. And so here I have the structure of each of my data frames below. I have my territories, which has a state and a territory. I have my event hub, which has a whole bunch of information specifically from event hubs, the enqueued time when the message was posted, the publisher, the partition. But the main thing I'm interested in is the structured data element at the bottom, where I have my transaction information with my customer ID, my sales information, and my state. And so now I've got my stream going. Again, I'm going to have my throughput records here, my batch duration, and then here at the end, I have my aggregate amounts. And so now instead of 50 aggregates that it's keeping the state of, I only have 10 because I only have 10 territories instead of 50 territories. And so I have my total sales by territory streaming there. And then as new transactions come in, that will automatically update. So I went from Mountain having 100 to 132. You'll see those increase as you go along. You could also look at them this way. Graphs are always fun. And this will just continue to stream and combine that static data of the territory information with my streaming data of my sales as they come in. And so that was using just an inner join. So I was just joining only where that was the case. I could also have a case where maybe I didn't have some data in my static table. So in this case, I'm going to use a left join for this sales territory missing. So I'm not a file where I don't have all the states in it. And so what I've done here is I did a transformation where I said, if I don't get a territory, then just put no territory so that I don't end up with just null values coming out at the end. And if I start that up, and this again will start, since it's its own configuration, its own checkpoints, its own stream, it'll actually start itself. It'll actually start with no information because it's starting at the end. It'll just sit here and wait till it gets some information sent to it. And then if I get some additional records sent in from my event hub, it will trigger up this aggregation, which is a similar aggregation. I'm getting my total sales by territory, but in this case, I just don't have a territory for every possible state when the data comes in. But I'm not losing those transactions because I'm utilizing a left join in my streaming to structured table join. So now I have should have a no territory, which is actually most of them. And then as it continues to receive more and more records, it will continue to increase and update that in real time as it moves forward. You can also see that this one is still streaming as well, because the Northeast up here has 15,000 records, where Northeast here only has $3,000 because they were started at the end of the stream, and the stream's continuing to flow, and they're aggregating the information in real time. The other kind of stream is a stream-to-stream integration, where stream-to-stream join, where you're actually joining two separate streams together. In this example, I'm going to do two event hubs, but because I like event hubs. But you could also do event hubs in file stream. You could do Kafka and event hub, or any combination of two or more. Like I said, I had some that had a lot of joins, which doesn't work out the best, but that it is possible to do. And then the thing that we'll look at in collaboration with that is the idea of watermarking and time constraint. So in the case of an inner join, if you're doing an inner join between two streaming tables, those are optional. I'll say they're optional, but when we get to some of the actual, when we actually look at it, it is almost always better to have watermarking unless you're absolutely positive that you're going to have a record in both tables for each one. If you don't, what happens is that they start to pick up state. So if I have 100 records come in for one stream, and then only 50 matching records come in for the other stream, if I don't have this idea of the watermark, it will leave those other 50 records in memory forever. And as you continue to run that stream continues to run, those will continue to increase. So it's always better to have the watermark even on an inner join where it's optional. On left and right outer joins, the watermark and time constraints are both required, and we'll talk more in detail about those and what that really means. So in this example, I'm actually going to have two streaming, and then you can also tie in. There's nothing that stops you from then tying in static files as well. So you can have two or more streams with two or more static files, join all of those together to create the data set or analysis that you need for your end user. So what are, I said watermark and time constraint a bunch of times. I probably should explain what they were before I went on to that slide, but so a watermark is really how late a record can arrive and after what time can it be removed from the state. So I was saying, so I have a record come in, no matching record comes in for 5 minutes, 10 minutes, an hour. How long am I going to let that record sit there and wait for its matching record to show up? That's really what the watermark is, and that works on both sides. So if I had even a left join where I had a record on the left but not an equal record on the right, the record on the left would stay as well. The time constraint is how long the records will be kept in state in relationship to the other stream. So if I have a transaction come in and then there's a refund, how long am I going to wait for that refund transaction to come in? Am I going to wait an hour? Am I going to wait a minute? How long am I going to, how close does that record have to be? And we'll go into an example here in just a second. And this is really only used in stateful operations. So it's only in the case of like a static to static join, that wouldn't make any sense. Just in the case of, or even a streaming to static, it wouldn't make any sense because you're always going to have all of the records available to you from that static source, where you will only have the micro batch records available to you for the streaming data frames. And it's ignored if you're in a non-stateful streaming query or some sort of batch query. It's not going to, the watermarks won't even be used. So kind of looking at an example. So let's say I have, in my example here, I have my two event hubs coming in. I have, both of these are streaming. I have one that has transactions and then one that has views. So an item is generated when you buy something on my site, and then an item is generated when you just look at something on the site. Both of them give me information about the item, information about the customer, the time, and I have both of those separate streams of information streaming into me from two separate event hubs coming in. So when I bring that information in together and join it, I want to set some rules about it. So I want to say that I'm only going to wait, that my transaction record should never be more than 10 minutes late. So I should never have a transaction that occurs at 10 o'clock and I get it at 10:12. If it's that late, I don't want to keep track of it. You can make that, this time I've seen it anywhere from seconds to hours. It could be any number of things. Same thing here, I have a view item. So if I watermark for 5 minutes, it means that it's only going to wait 5 minutes. It's only going to keep that record if it's within 5 minutes of when it was created. So it gets that. The time constraint then says, how do these two things relate together? So it's like the where clause of a normal SQL join. So in this case, what I'm going to say is that the view record has to be created after the transaction record, and the view record has to be created before 5 minutes after the transaction record. So in my analysis of that I'm working on here, what I really want to know is when a customer buys something, how many things do they look at in the next 5 minutes? And so what I'm doing is having these streams, and the way it works is it holds these records for the longest time between the interval amount, so this 5 minutes plus the 10 minutes of the watermark. So it would keep this record for 15 minutes in the stream because there's some math behind that. And then once it either finds that record or doesn't find it, it will either drop the record out or send on the result onto the next step. And I'll have a demonstration in a minute on that. So here's kind of a timeline example that I was kind of talking about before. So I have my transaction that comes in at 10 o'clock, or that occurs at 10 o'clock. Well, I didn't get it till 10:01. Well, it's still available for 10 minutes based off of my watermark time. So it is within the watermark. So I'll still be able to use that record. Well, then I had some events, some items messages start to come in. So I had this item number one, view number one, view number two. Those are fine. So those are within my 5 minute time constraint. So between the start, the actual time of the message and the time interval, so between 10 and 10:05, any messages I receive in there are fine. So I get this message here that is view number three. So it occurred at 10:04, which would have been fine. That is definitely within my constraint time, within my watermark period, and that would be fine. But I didn't get it until 10:06. So what happens there is that actually should be green, because that is fine as well, because even though I got it here, it's still within the watermark period, and so I will still be able to process that record. Maybe it's this one. I don't know. Where's 4? I don't know. I think I got one of these off. And then here I had 5 occurred. Well, 5 occurred, but I didn't receive it until 10:12. Well, that's outside of my watermark period, so I've already lost this record in the case of a stream, and so I wouldn't be able to apply that record even though it is within the time frame. Oh, I know what so this view number 4, I now remember, view number 4 is actually here, occurs at this time and is received at this time. Well, that's outside the constraint time, because the constraint time is only 5 minutes. So I wouldn't be able to get that. So then we have our last one. Our last example is view number 6. Well, I didn't receive this transaction until 10:01, but I got this message at 10:00 and 30 seconds or something. So I got it actually before I received the transaction, but because of this watermark, it's going to wait this amount of time to see if a transaction comes in before it ends up dropping off that first message. So hopefully that's kind of clear as mud. Watermarking and time constraint are the most confusing, to me at least, elements of this. And this may not be exactly right. I think it's pretty close. I'm always like, I thought that record would have dropped off by now, but it didn't. So that's the idea, is that as long as it occurs, generally within the window of the watermark and generally within the constraint time, that's usually more specific. You should be able to pick up those messages. let's do a little demo and see if we can get that to work. We'll go over here, take a look at a couple of things. So I have my transaction stream here that I'm going to start up, and then I also have my view. I have my view stream. So I have two separate streams. They have different connection string information. They have different schema formats. Have some different columns maybe depending on what they are. So this one has customer ID, customer and an ID and a timestamp. This one also has those same columns because that's what we're interested in this particular analysis, is just the action of buying or viewing. So then down here we can look at, this is that our first example where we're just doing an inner join between the two. I could do this, I don't need the watermark, but what would happen is if I never received any views for that transaction, which is very possible. It could have been you were purchasing something, you bought it, you left the site and didn't view any other information. Those transactions that didn't get a corresponding view would just sit there forever. So what this watermark does is that tells us that we only want to wait 30 seconds. If we don't get a view, it was 10 minutes in the presentation, but for brevity in my demonstration, I cut it down to 30 seconds so that we could see that things go away. And same thing, I did the same thing there with the views. So if I don't receive any records within 30 seconds, it's going to go away. And then I also left the interval at 30 seconds. So any views that occur within 30 seconds of that transaction are going to go into our analysis here. So we'll trigger off some messages. And so we started getting some information. We have our customers, our transaction numbers, our items and what time they occurred. The other interesting thing that it took me a while to figure out, and I don't remember where I finally figured it out from, but it's not the watermark isn't from the current time, it's from the last time that the stream saw. So if I had this time here, maybe it's already past 30 seconds. That's quite possible that we're already past 30 seconds on that, but it hasn't dropped out any of the it hasn't dropped out any records yet because it is actually waiting for additional messages to be received before it does that. So I think it got some additional messages. And so these are all interjoined, and so they're going to so you're only going to have complete messages where you have both the transaction information and the view information together. We go down to the next one, it's kind of the same thing, but we're using, in this case, a left outer join. So we're joining these together. We're joining where the customer ID is the same. They're not the same transaction, and then they're within our time constraint window. So if we start this one up, and then display it. And you can also see, as I was saying, you can also put static tables. So I had our territory table again, and I was able to join that to this information. You could do a left join or an inner join for that. So I'm getting some messages coming in. I should See those pop here in just a second. And if any of them match up with each other, I'll start to see those messages match up. And then at some point in about 30 seconds, you will start to see some of the transactions drop out. Those transactions that never got a view in about 30 seconds. Where in that time frame? A little jumpy. Maybe I should have made it 10 seconds. There we go. Oh, we dropped out something else. Oh, there we go. So here we go. So let me stop it. So then if I scroll down to the bottom of my results, I'll start to see all of these where there was no view item. So after the watermark was exceeded and the time constraint was exceeded, it then started dropping those records out because they were in a left join, and so I was able to get those as well. So in the first example, I didn't get these records; they just went away because they didn't match up with another record in the stream using in the join in the other stream. But in this case, I was using a left join, so they ended up coming together. All right. Because of my technical difficulties at the beginning, we're going to run a little short here, but we'll try to grab that. Another really cool feature you can use in streaming is the for each batch. What this does is it allows you to kind of cheat. So it allows you to do batch type processing, but perform it on streaming data. Some of the things that I've used this for a lot are for drop duplicates. You can do that on a streaming data set, but again, it keeps that state and takes a lot of memory and can cause problems down the road as you build more and more messages, more and more non-duplicated information builds out there. It can really cause issues on your system. But if you are just looking for duplicates within each micro batch of transactions, you can do that drop duplicate within a for each loop and only do it for the 100 records that you have within your micro batch. You can also do aggregation there if you know that you're going to have all the records. So in the case if you have really complex messages where you have maybe an entire ticket in one message and that ticket has multiple items and you just want to summarize by item, you can do that aggregation in that for each batch instead of, again, aggregating at the stream level, which can cause you a lot of issues with keeping with all your state. You can also perform things like merges and upserts. You can do against existing static data sessions so that you can update or insert new records using that. You can also write to multiple syncs. So instead of just being able to write it out to one location, you could write out to multiple locations in multiple formats. You can also kind of cheat and do other syncs that aren't supported normally by structured streaming. So any sync you can do that. So what that looks like, we'll jump to that. That's about the last thing we'll have time for. So the way that looks is, again, we have our kind of same standard streaming that we got, but when you go to write the data, you have this for each method. And within there, what I'm doing is I'm saying, give me as a standard data frame instead of a streaming data frame, give me that information for each batch as it goes through that looping process of the stream. So for every one of those 100 messages that I've limited myself to, let me do whatever steps these are. So in this case, I'm doing an aggregation to find the last transaction, and then matching that up to an existing table and updating or inserting records as needed for that. And at the same loop, I'm also updating my detailed transactions and doing kind of the same thing. So I have two separate syncs, one using aggregations, one not, and all of that in the same streaming loop as it goes through. It is a little more resource intensive, but it allows you to do some really cool things that you wouldn't otherwise normally get to do. And I will not run that just because we're out of time. And some other last minute things. This could be an entire webinar. It might be in the future. There's some really good stuff out there. There's a real good session you can look up from the Spark AI 2020 Summit that does a really good job of kind of really describing those. Maybe I'll try to stick that in the chat here in just a second. But these are some of the things to kind of look for as you move to production. Some of these are important to think of kind of up front. The shuffle partitions, that gets set in your checkpoint. So if you start with one shuffle partition and then you have to, you start with one thing and then you have to, scale up your resources for whatever reason, or scale down your resources because you provided too much, it's hard to change that afterwards. So that's something to kind of watch for. The output table elements, these are really important to be able to repartition, and this auto optimize is an amazing thing, especially with streaming, where if you're using Delta Lake file tables as your sync, that's where you're writing the information to. This allows you, instead of having one file for each message that comes through, so in the case of my 10 million message customer, 10 million files a day that have to be out there and have to be picked up and worked with. It automatically combines those and optimizes the size of those files so that it combines multiple messages together, which is a really, really cool feature. And then some of the other kinds of things, there's a lot of tweaking you can do based off of the shuffle index. So the shuffle index is where it writes information out as it's trying to process data. It writes information out to the disk. Just like on your regular PC at home, that's bad. If you're writing things out to disk, that's a lot slower than doing it in memory. Try to do everything we can in memory. So lots of these things, the size of the size, number of files or triggers that you're processing, the number of shuffle partitions, even the size of your cluster and Databricks, all of those things are to try to keep that from happening. And then anything you can do to kind of limit that statefulness that we've been talking about with the watermarking, or doing aggregations, or multiple streams together, all of those things. So I had the example of 8 separate streams that I was trying to join together. That was a terrible design, and so we ended up going back and redoing it, and ended up just being one stream, which processed in about 1/10,000th of the time of the original stream. So those kinds of things are good things to keep in mind. And like I said, there's some really good resources out there on performance tuning that you're streaming batches. Or maybe I'll do a webinar on one of those one time. Hopefully I have more time. So I think that's all I got. Again, sorry for the technical difficulties at the front that cut us a little short on time, or having you run over. If we do have any time, we could take some questions. I don't know. Can we take questions? Crystal?
We can give a few seconds for questions. I don't see any in here, except for how have you set up your event hub, I believe?
Sure. I was trying to, where's the question? So yeah, they're just standard event hubs. I just have an event generator on the back end that's generating the messages for me for the demonstration purposes. But you can have in your event hubs, you have your namespace, and then from your namespace, oh, that's not the right one. Don't name everything the same. You can have multiple event hubs. So I have a hub or an endpoint for each one, for customers, for items, or for views, and then for transactions. And I can post and pick up messages from either one of those, from any one of those as I need to. Hopefully that was the question.
Okay, that looks like the last question on here. So, Brian, thank you so much for hosting. We greatly appreciate it. As always, guys, thank you guys so much for coming in and tuning in, and we hope to see you guys in the next webinar. As always, you guys will receive an email link tomorrow, probably around 1 p.m. Eastern Standard Time, with the recording in here. And if you guys are looking for any of our other recordings, you guys can visit our YouTube channel at Pragmatic Works under our free training playlist. Again, Brian, thank you so much for hosting. I hope you guys have a good rest of your Tuesday and stay safe.